Hi folks, Mr. Long here. This is a screencast where we're going to solve exponential equations with the strategy of getting a common base. So the first exponential equation we're going to do is right here, 3 to the 4x equaling 3 to the negative 20. Please remember that this negative 20 is not a power, it's an exponent. The 3 combined with the exponent of negative 20 is a power. I know it's hard to unlearn after years of doing that, but it helps you in terms of the vocabulary, in terms of understanding. So, first question we always ask is, does the equation have a common base? Well, it does. 3 equals 3. If the bases are the same, it follows then that the exponents are the same. So, since 3 equals 3, 4x has to be equal to negative 20. So I type in negative 20 there. Okay, so 4x equals negative 20. Now it's just like a regular linear equation from grade 9, 10, and 11. So it says here, to solve for x, what did you do to both sides of the equation? Well, this says 4 multiplied by x. What's the opposite of multiplying x by 4? Dividing by 4. So I click on divide here, and I divide by 4. That means I'm dividing on both sides by 4. 4x divided by 4 is just 1x. X. Negative 20 divided by 4 is negative 5. Okay, and we're done. Number 2. 6 to the x minus 2 equals 1,296. Do those have a common base? No. So the first thing we need to do is to get a common base. So I've got to find, in my power chart, I've got to find a row where there's 6 and 1,296. That's pretty easy to find. There's the 6, 6 squared, 6 cubed, 6 to the 4th. Okay, 6 to the exponent of 4 is 1296. So that means I can replace 1,296 with 6 to the exponent of 4. Okay, 6 to the exponent of 4. So now, do I have a common base? 6 and 6. If I do, that means that x minus 2 has to be equal to 4. Okay, x minus 2 has to be equal to 4. So what I want to do now is set those equal. There's my equation that needs solving. X minus 2 equals 4. Well, I need to isolate for x. Right now, x has 2 being subtracted from it. The opposite of subtracting 2 is adding 2. So I go over to here. I know that it's plus 2 is the opposite of subtracting 2. And then it becomes 4 plus 2 is 6. Okay, 4 plus 2 is 6. Again, pause, rewind, go over these as you need to. Number 3. Now this one is weird. Okay, so you first look at this and you go, that's 7, and that's a 7, so I have a common base. But do I? Well, sort of. This says 1 divided by 7. And this is something I know people at times struggle with, but that says 1 divided by 7. We remember that positive exponents mean repeated multiplication. It follows then that negative exponents mean repeated division. And this says 1 divide by 7 once, right? When there's no exponent on the 7, it means there's 7 multiplied by itself once, right? Or just multiplied by 7. Not by itself, but multiplied by 7. So it means divide by 7 once. How do I show that? With an exponent of negative 1, right? That's because it's dividing, okay? So now I have a common base, 7 and 7. And 4x plus 5 equals negative 1. And I would go through and solve that, okay? So 4x plus 5 is negative 1. Well, I need to isolate for x, so the first thing I've got to do is subtract 5 from both sides. And what I've got to do here at line 2 is then, what I've got to do here, let's see, what is that going to be actually? If I have to minus 5 on both sides, right? So if I minus 5 on this side, I'm only going to be left with 4x, right? That minus 5 disappears. And then over here, I've got negative 1 minus 5 is negative 6. Okay, so then Now I need to divide both sides by 4. Again, you can be using a calculator, of course, right? So divide both sides by 4. Negative 6 divided by 4, use your calculator, negative 1.5. Okay, so if x equals negative 1.5, then our value will be balanced on both sides. Okay, the value of each of these will be the same. Number 4. Okay, I need a common base again. 125 here, 5 here. So I need to go and find the row with 5 and 125. There's 5. 5 squared is 25. 5 cubed is 125. Okay, so it's cubed. So for this one, it looks like I need 5 cubed. So I start with a 5 here. And this is going to have to be 3. 5 cubed is 125, but I still have the x minus 4. Now what exponent do I put on regular old 5? That's 5 to the 1. Okay, 5 to the 1. And so now, do I have bases that are equal? Common base, 5 here, 5 here. If the bases are equal, it follows then the exponents are equal. So I put a 3 there, and then I put a 1 there. And now I need to solve this equation. Now there's a variety of ways to solve this equation, some with just straight ahead inverse operations, but a lot of people seem to like to expand through the brackets. So 3 times x is 3x. 3 times 4 is 12, but I've got a minus sign, a negative sign in there. So I'm going to pick x minus, and it's going to be 12, because 3 times 4, again, is 12. And that equals not negative 1, but positive 1. Okay, so now what do I do? Well, same sort of thing that we've been doing before here. Oh, I need to, that should be 14 there. There we go, that's better. So, and it should be a different font. There we go, that's really much better. Okay, so 3x minus 12 equals 1. Well, I need to get x by itself, so the first thing I have to do is get rid of this minus 12. Well, what's the opposite of minus 12? It's to add 12. And I do that on both sides. If I add 12, it gets rid of this, and then I'm going to have 1 plus 12, which is going to be 13. Now on this side, I still have 3x. Okay, I still have 3x. And then lastly, what do I do next? It becomes 13 equals 3x over here. 3 multiplied by x, the opposite of multiplying x by 3 is to divide by 3. So then I divide by 3. Okay, divide by 3. 13 divided by 3, you could put a fraction, but it works out to be 4.33 repeating. Okay, so 4.33 would be fine. Okay, last one. Ooh, this is a nice one because look, I've got a common base here, 7 and 7, so I don't have to worry about getting a common base. I just have two equations, 8x plus 5, 10x minus 13. So I just write that in, 8x plus 5, 10x minus 13. Now, I have variables on both sides, x's on both sides. I always eliminate the side with the least numbers of x's. This has got 8x, this has got 10x. So if I want to eliminate that 8x, and that's a positive 8x, I have to subtract 8x. But if I subtract 8x on one side, I've got a minus 8x on the other side as well. Okay, I'm going to minus 8x. Whoops, not just 8, but 8x on both sides. Okay, so that's 8x minus 8x is I'm going to make that gone. So I'm going to be left with just 5 there. Then on the other side, I've got 10x minus 8x. That's going to be 2x. Then I'm going to have minus 13. Okay, so 2x minus 13 on one side, 5 on the other. I want to get 2x by itself at first. So the opposite of that is to add 13. Okay, that's adding 13. Then over here I've got, I need to add 13 to both sides, so 5 plus 13 is 18 on one side. And then I've still got 2x over here. Okay, and now the last thing I'm going to do is to divide by 2. Okay, divide by 2. So 18 divided by 2 is 9. And 2x divided by 2 is just 2 groups of x divided by 2 is just 1x, okay, or x. So x equals 9. I don't have to worry about this last little bit, okay? I gave you an extra spot here that you didn't need. So 9 equals x. Okay, so again, you can pause, you can rewind. That's about a 10-11 minute video. It goes through two things, really, solving exponential equations, but also just solving regular, what are called linear equations. All right, so take your time, go back over things as you need to till you get the hang of it. Have a good day.